Hi, everybody. We're going to start today with some solving real-world applications with logs. So if you look at the do now, they're talking about a scientist in a lab and they're raising amoebas to sell for schools in bio classes. So they tell you that one amoeba divides into two amoebas every hour, and this is your formula. T equals log base 2 of n, and that's going to determine how long it takes in hours, t, to produce a certain number of amoebas, n. Determine to the nearest tenth of an hour, so that's this, how long it's going to take to produce 10,000 amoebas. Okay, if they start with 1. So when you're given your formula, t equals log base 2 of n. The piece of information that we know is that how long is it going to take, that's T we're solving for, to produce 10,000 amoebas? So here, all you really need to do is plug in 10,000 for N. And when you go straight into the calculator to do log base 2 of 10,000, you get 13.2877. And if we're rounding to the nearest tenth, we get 13.3 hours. So that one wasn't so bad. This next one was actually a Regents multiple choice question. It says they give you this whole lot of information about sound and decibels. So you could see your decibels, and the units are measured by your first intensity, I sub 0, to a very soft sound that is called a threshold sound. The sound to be measured is assigned by the intensity I and the decibel rating D. And here is your formula. D equals 10 log of I divided by I sub 0. And they tell you, okay, so here's what they tell you. If the threshold sound audible to the average person is 1.0 times 10 to the negative 12ths, consider the following. They want to know how would it sound with intensity of 6.3 times 10 to the negative 3 be classified? God, so much info. So we're going to first take our formula. So we know that D equals 10 log. You know it's base 10 because there's no base there, and they have I divided by I sub 0. So we're just going to plug in for either of those. So both of those, I should say. 10 log, we know it's base 10, so if you're not sure, you're going to, when you go into the calculator, use base 10. And your I is your intensity. Your intensity, here's your intensity. This is your I. Here's your numerator, 6.3 times 10 to the negative 3. And we know our I sub 0, which is your first intensity, is this. Okay, this is your I sub 0. Your 1.0 times 10 to the negative 12th power. So just be careful when you are actually plugging this into the calculator. Again, if you don't see a base, your base is 10. You're going to use the button in the calculator that has a base of 10. And when you type this in, you get something like 97 point, I think it's 993. And if you look back to your table up top, that is classified right in between the very loud category. So that would be your answer, number 3, which is very loud. So much info. Okay, so I'm going to move on to number 2. And number 2 is kind of basic. You have 2 parts. Your first part is just giving you a current population of 62,700, and it's increasing at a rate of 3.25%. Write your function. They're giving you, that's all they want you to do. Write a function in P of T, which represents the total population after T years from now. So as basic as P of T equals 62,700 times 1.0325 to the T. Remember, that's a basic growth formula. Don't forget you need 1 plus your rate, and your rate is always turned into a decimal. And then in the second part, they just are asking after how many years to the nearest tenth, so that's important, nearest tenth, will it take for the original population to reach 100,000? 100,000. And they do say to you that only an algebraic solution is going to get you full credit. So you have to solve it algebraically with logs. So if you now know the population is 100,000, you're going to take your formula and plug in that 100,000. And remember, our goal is to solve for t. You have to get rid of this 62,700. Now, the 62,700 isn't a nice number when you divide it, so you're going to kind of keep 100,000 over 62,700, and that equals the base of 1.0325 to the t. Now you're going to use logs. Remember, and I'm running out of room, a log is an exponent and the base never changes. So here's your base, log, here's your base 1.0325, okay, of this number, 100,000 divided by 62,700, and that's going to equal your exponent of t. So when you go straight into your calculator, I'm going to go into the next page, sorry. It's going to wind up being 14.5955, something like that. And when you round to the nearest tenth, you get 14.6 years is your value for t. So that was not terrible, but just a little bit of work. And understanding that if you want to get an accurate number and you don't get a nice number when you divide 100,000 by 62,700, keep that fraction. Okay. In number 3, we are talking about radioactive decay. Okay, and they're giving you this half-life formula. And they say if a given substance has a half-life of 6,000 years, after t years, so this is important information. They're telling you your half-life, that's your H, is going to be 6,000 years. After t years, 1/5 of the original sample remains radioactive. Find t to the nearest 1,000 years. Okay, nearest 1,000 years. So not thousandth, 1,000. Okay, so let's talk about this formula. If P equals, we could use a half or 0.5. I'll use 0.5 like they do in the formula. And they give you T divided by H. Okay, so they want to know where P is part of the substance with the half-life. Well, here's what you know. You want to know 1/5 of the original sample. That's what's going in for your P. 1/5 of your original sample. What's the original that they told you? Your original is, they tell you 1, right? A given substance. It's 1, 0.5, and now you're going to have your half-life of 6,000. Okay, if after t years, 1/5 of the original sample. So I think you're just going to assume that if you're putting in your one radioactive decay, one piece of the substance, and it gets to 1/5, those are just like the easiest numbers to use. 1 and 1/5 of 1, which would be 1/5. So here, if you're going to solve for t, you got to use logs. And if I really don't need to divide by 1, I'm going to just rewrite this without the 1. Technically, remember, you're going to say your log base 0.5 of 1/5 is equal to your exponent t divided by 6,000. Okay, so I just wrote that using logs. I didn't need to divide by 1. I would still get that same 1/5. Now here you have this 6,000. So we are just going to show that we're going to multiply both sides by that 6,000. Okay, so now you're going to get what T equals. When you go into your calculator, you're going to do 6,000 times, and these parentheses are necessary, must put into calculator. Must use parentheses for the calculator. Okay, so you're going to do 6,000 in a parenthesis, log base 0.5 of 1/5. You should get, I think it's like 13,931.5685, something like that. That's your value of T. And again, thousand, not thousandth. So you're rounding this to the nearest thousand. Is it 13,000 or 14,000? Clearly, this is 14,000 years. Okay. Okay, I'm going to do one more with you guys. Okay, if you guys go to number 4, it says the stock price of Wind Power Inc. is growing, and here's that word, continuously. Very important. You should be thinking about a base of E in the PERT formula. At a rate of 4% per week. Its initial value is $20 per share. The Wind Power Inc. will give employees a raise once the price triples. Okay, so that's important. Triples. Determine algebraically, okay, so there's that word, algebraically, after how many weeks the employee will receive a raise. All right, so there's no formula that they gave you, so I'm just going to assign a few variables. I'm going to make T equal our number of weeks. And I'm just going to call it W of T because it's Wind Power Inc. is going to be my stock price after T weeks. Okay. So if I now know W of T, I know that my initial price was $20, and I know that it's growing exponentially. So I'm going to do E, and I'm going to raise it to the 0.04 T. Okay. So what's the only other thing they told us? They told us that they want to figure out how many weeks after the price triples. Okay, so let's talk about it tripling. If I take $20 and I triple it, it's going to be when the price is $60. So we are now going to solve when will $60 be equal to 20 to the base of E to the 0.04 T. Okay, so if we solve that, going to get rid of your coefficient, divide both sides by 20, and you have 3 equals a base of E to the 0.04 T, which tells us we're using natural logs. That base of E, rewrite it with a natural log. So I am going to write underneath here that, again, a log is an exponent, and the base doesn't change. So the natural log, you don't have to write the base of E, of 3, is going to equal my exponent of 0.04 T. And that last step, divide both sides by 0.04. Okay, go into that calculator, and you're going to get something like 27.465, something like that, is T. So after how many weeks, they say to the nearest week, determine algebraically after how many weeks, I would say 27 weeks. Okay, guys, I'm going to stop there. You have a few questions left, but we're going to save those for tomorrow. Okay.